So now we are in our chapter 2 already, which is linear second order differential equation, right? So we have done with first order differential equation, but for this second order, for the chapter 2 here, we proceed with linear second order differential equation, all right? Okay, so now let's take a look at the contents for this chapter. We have the basic definition, terminologies, how to solve homogeneous, how to solve non-homogeneous. Okay, we have methods of undetermined coefficient, methods of variation, how to solve higher order linear ordinary differential equation. So instead of second orders, maybe we can have up to third or fourth order of linear ordinary differential equation. Then at the end of the process, here we are going to discuss about the application, okay, where there are two applications here, mechanical vibrations and also RLC circuit. Okay, like that. So now you have done with first order and this chapter is focused on second and higher order. So how can we identify the order of differential equation? Remember, anyone?
By looking at the highest derivative.
Yes, by looking at the highest derivative or highest differential. Just like this. This is a general form. Okay, this is the general form of linear differential equation of nth order. So this is nth order and minus one order until first order. Okay, second order. So this is the general form of linear differential equation. Okay, this is the function of linear differential equation equals to fx, right? Where a0, a1, up until an are called coefficients. And fx is a function of x. Okay, for this linear second order differential equation, if fx equals to 0, this one, if your function in the right hand side here equals to 0, then we call it as a linear homogeneous equation. And if it does not equals to 0 means there is, in terms of function, maybe a constant, maybe a linear, maybe a quadratic, maybe a exponential, maybe a trigonometric function. Okay, as long as there is something in that fx which does not equals to 0, then we can call it as a linear non-homogeneous equation. So for this chapter, we're going to proceed on how can we find the solution of linear homogeneous and linear non-homogeneous equation. Okay, so now in terms of solution, if you have, okay, up to second order, okay, you are going to have two solutions, right? So this is the general form of second order linear differential equation. So a described y over the x squared plus b dy dx plus cy equals to 0. So this is second order linear differential equation. So previously, what we have done, linear first order differential equation, we only have one solution, right? How can we solve exact? How can we solve linear? How can we solve separable? For chapter 1, we obtain only one solution because that one is for first order. Now, for second order, we are going to have maybe up to two solutions. So, our general solution is to combine both solutions. All right. So, our general solution is to combine both solutions. So, if you have second order, you will have up to two solutions. Combine both. If you have up to nth order, you are going to combine all number of solutions up to n solution, where we use the linear superposition principle. So the process of adding all solutions all together here is used basically based on this principle, linear superposition principle. Okay. All right, so this is second order. How can you know that this is second order? By looking at the highest derivative. Okay, and this is a function with y dy dx, a function with y, Okay, so this is linear and it equals to 0 means this is homogeneous. Linear, homogeneous, second order differential equation. Okay, understand all of you? So we have done with understanding the general form. Now you know the right hand side function of fx can either be 0 for homogeneous, cannot be equals to 0 for non-homogeneous. Okay, and the solution maybe we're going to have two solutions. So our final solution we just add up together, combine them together to get one solution by using linear superposition principle. Okay, so that is the basic definition and terminologies of second order differential equation. All right, so now how can we find the solution? So solution to homogeneous equation. All right, let's take a look. Okay. Right, I'm going to use the previous note that I have been explained in section 33 early in the morning. So let's just discuss this. Okay, now this is the general form of second order. Okay, all right. And this is for linear homogeneous because you know that your function in the right hand side equals to 0. So when your function fx equals to 0, then we can say that it is linear homogeneous second order differential equation. Okay, so how can we find the solution? All right, first we need to convert this differential equation to characteristic equation where d squared y dx squared equals to m dy dx equals to m. Okay, and then y equals to 1. So just substitute here. This one with m squared, this one with m, this one with 1. So basically, from this differential equation, after you convert by using characteristic equation, now it becomes quadratic equation. Okay, where does this m comes from? Let's take a look at the notes we have there. We have some assumption. Okay, this is your differential equation. Okay, our aim is to find the solution of this equation. All right, we want to find the solution of 1. So this is your 1, the first equation. Assume the solution. Okay, we need to do some assumption here. Assume that the solution is in the form of y equals to e to the power of mt. Thus, we have when y equals to e to the power of mt, then dy dt is memt. D squared y dt squared is m squared emt. So just substitute to the second order here. And if the solution to 1 is y equals to mt, then it must satisfy 1. Therefore, if we substitute all terms in the second and first equation, we will obtain the characteristic of equation here, which is quadratic equation, this one. So we use this assumption, we differentiate, we substitute here and simplify to get this. Okay, so this, where does the characteristic equation comes from? Okay, so now from this second order differential equation, by using characteristic, it can be this quadratic equation. So by solving this quadratic, we are going to have 3 types of roots. Okay, the first one, roots are real and distinct. So when the roots are real and distinct, this is the solution of the differential equation. Y equals to aem1x plus bem2x. Just substitute what are the roots that you obtain here in m1 and m2. Okay, and the next type, if your roots are real and equal, then this is the solution of the differential equation. Y equals to e to the power of mx times a plus bx. Just have only one m because both m have same value. And then the last one, if the roots are conjugate or complex number, okay, in terms of alpha plus minus beta j. So the solution is equals to exponent to the power of alpha x times with a sine beta x plus b cos beta x. Okay, clear not? Understand? Everyone? Okay. So now let's take a look at this. First, you have the differential equation. Y double prime plus 5y prime plus 6y equals to 0. Okay. First step, you need to convert to characteristic equation, which will give you what? M squared plus 5m plus 6 equals to 0. So solving this, you will get m. Okay, what are the values of m here? Okay, minus 2 and minus 3. So identify the types of roots. Minus 2 and minus 3 is a real number and both are different or distinct. So we are going to use the first solution here as the solution for this differential equation. Then this is how we do it. Okay. So m is minus 2 and minus 3. Just substitute your m1 and your m2. Okay. Or vice versa. Same one. Both are correct. Right? Clear? Same with this one. M squared minus m minus 11 equals to 0. So you're going to have in terms of decimal. Decimal is still a number, is still a real number, and both are different. Then this is the solution. Okay? This is real and distinct roots. Okay, what if you interchange? A is here, B is here, doesn't matter because A and B are both constant. All right? Okay, clear everyone? This is for real and distinct. Anyone has question? Okay, next, try example 3 and 4 here. We have y double prime plus 6y prime plus 4 plus 9. Okay, equals to 0. As you can see, for this example, all of them are equals to 0. So this types of solution is applicable for a function or equation which equals to 0, which is homogeneous equation. Okay, convert to characteristic equation, solve this quadratic, you get your m, and this m are real and equal. So use real and equal types of solution. Okay, and then this one, substitute to the characteristic, find the roots, and you have 5 plus minus I, which in terms of alpha plus minus beta j. So alpha is for real part, and beta is for imaginary part. So just substitute alpha here and beta here. Alright, clear? So these are three types of solving a homogeneous second order differential equation. Alright, anyone has question? Okay, why don't you try this example? Example 5. We have y double prime plus 6y prime plus 16y equals to 0. But now we have in terms of condition. Okay, how can we apply the condition? Okay, find the solution first. Example 4, why is it cos x? Because beta here is 1. So A cos beta x plus B sin beta x. Okay? Oh, this one. Doesn't matter actually, A and B. A cos beta x sin beta x or A sin beta x cos B cos beta x. Okay? Both are constant, right? It's just an arrangement. If you want to change this as sign, it's okay. Both are correct. Right? Okay, what are the solution? For example 5. Up to y only. No need to apply the condition yet. You got your characteristic equation, right? Where it is m squared plus 6m plus 16. Okay? All of you got this? Then okay? Then you have the roots, which is complex roots, right? And then substitute the solution, and you know that y not equals to 1, y prime not equals to 0 means this is the condition. Okay, when x equals to 0, y equals to 1. When x equals to 0, y prime equals to 0. So for the first one, just apply to the solution. Substitute x with 0, y with 1, and then you can obtain the value of a. And for the second condition, you have y prime 0 equals to 0 means you need to have y prime first by differentiate this. Okay, by using product rule. Then apply the condition to get B. Then substitute again in A and B. Then you will have the particular solution. All right, is that clear? This is how you do it. Okay, take your time. If you have question, you can ask. And if you want to proceed, please let me know. Okay, so for homogeneous part, all right, for homogeneous part, as long as the right-hand side equals to 0, okay, convert to the characteristic equation, find the roots and identify the types, and that's it. Those are the solution. Okay, once you have a condition, just apply the condition in order to find what? The constant. Okay, so the condition is only applicable in order to find the value of constant so that we can have the particular solution. Okay, that one is how we solve homogeneous equation. Okay, now let's proceed with this. Okay, try the partial test here. This one. Find the solution. Same process with the previous one. Okay, you have the differential equation. You are given the condition and then apply the condition to find the constant. Okay, try it. This is quite easy. 4 marks only. I'll give you around 4 to 5 minutes. Okay, the next one is how can we solve non-homogeneous equation? Okay, right. So now What is non-homogeneous? So the difference between homogeneous and non-homogeneous is only at the function of the right-hand side. Okay, the differential equation is equals to fx. Now fx does not equals to 0. This fx does not equals to 0. There's a certain value on that fx. Either can be constant, linear, quadratic, polynomial, trigonometric, exponential, and so on. Okay, so what if this function has value? So you will need to consider the right hand side function so that we can come out the final solution instead of solving the left hand side part only. Okay, so the solution will be given as y equals to yh plus yp, where yh here is the solution for homogeneous part. So how can we find the solution for homogeneous part? Just like what we did previously in homogeneous solution. And then we should add with yp. So yp here is the particular integral, is the solution of the right hand side function. Okay, YH is the solution for the homogeneous, alright, and YP is the particular integral. Okay, how can we find YP? Because YH is quite easy, alright, just like we did in our homogeneous solution. Now, how can we find YP? So there are two methods to determine YP. The first one is method of undetermined coefficient, and the second one is method of variation of parameters. Okay, so let's just focus on the first method first. Good. Now, in method of undetermined coefficient, we need to consider these four cases. Okay, either that function is a polynomial, this function, or that function is in the form of exponential, or that function is a sine or cosine function, or the last one is that function is sum of the above cases. Sum of case 1, case 2, or case 3. Maybe case 1 plus case 2, maybe case 2 plus case 3, and so on. So these cases are only applicable in undetermined coefficient. Let's say if you have tangent, you cannot use undetermined coefficient. Okay, because we only consider polynomial, exponent, sine or cosine, or sums of the above cases. Okay, let's say you have secant, tangent, inverse sine. Okay, that one is not listed here in the four cases here. So maybe those kind of function we can use another method of variation of parameters. But for this method, undetermined coefficient, we need to consider only these four cases. Okay, so let's start with the first case, polynomial. Okay, now let's start with this one. The first case is a polynomial. Okay, polynomial can either be constant, can either be linear, quadratic, cubic, up until power n here. N has the highest degree. Okay, so if you have fx as a polynomial, then your yp is equals to xr, x to the power of r, times Cn xn plus Cn minus 1 xn minus 1 plus up until plus C naught. And then we need to choose the smallest r in order to ensure that no term in yp and yh are similar. Okay, let's take a look at this example. Okay, this is example from your notes. All right, is it too small or you want me to zoom the screen share.
Yes, doctor. A little bit.
Like this, okay?
Okay, doctor.
Okay, now let's take a look at this example. Okay, this is taken from your notes. You also have this in your notes, right? Okay, now you know that this example, you know that this is non-homogeneous because we have a function in the right-hand side function which is not equals to 0. Okay, so how can we find the solution? All right, first you need to find YH, where YH comes from the solution of the left-hand side. So you just need to consider the left-hand side, where you just assume it is equals to 0. Then it is identical. It is quite similar with the previous one that we have done, solving the homogeneous part. So changing to the changing to the characteristic equation and solve this quadratic, you get m equals to minus 2 and 1, which is real and distinct. So this is the solution of YH. Okay, the solution of the left-hand side part, the homogeneous part. Okay, now let's proceed with the how can we find YP. So since the fx, okay, since fx is given by 2x squared minus 4x, you know that this is a quadratic, and where this quadratic comes from the polynomial of 2 as the highest degree. Okay, and here now is the highest degree, which is equals to 2. Okay, so when your function is polynomial, then your YP equals to x to the power of r. Okay, YP equals to x to the power of r. The highest degree is 2, right? So C2x squared plus C1x plus C0. This is the general form of quadratic. Okay, since your function is quadratic, so your YP should have the general form of quadratic. Okay, now we need to choose the smallest r. Okay, so that we need to ensure that there is no term in YP and YH which is similar. Okay, now this is your YH. Okay, this is your YH. Right, now when r, okay, choose the smallest r, when r equals to 0, your YP equals to, r equals to 0, x to the power 0 is 1. So your YP equals to C2x squared plus C1x plus C0, right? So you need to check in this YP, is there any term in this YP which are similar in the term of YH? This YH has exponential of minus 2x and exponential of x. This YP has a quadratic x square here, linear x here, constant. So there is no similar term. Okay. Okay, sometimes we are going to have a similar term. So for this example, there is no similar term in YH and YP. So when there is no similar term in YH and YP, we choose r to the power 0 in your YP. So this is your YP. Then this is your YP. Okay, when r equals to 0, there is no similar term, then that is your YP. Okay, now this is your YP. What's next? Okay, as you can see, compare YP and YH. Any similar term? Yes or no? If yes, we need to do some modification. Okay, after this, let's discuss about similarity in YH and YP. But for this example, there is no similar term. Now, if no, proceed to find YP prime and YP double prime. Why? Why we need to differentiate this YP? Okay. Once you obtain your YP, all right, once you obtain your YP, your next step is take a look at the differential given. Okay, the differential equation given is y double prime plus y prime minus 2y equals to 2x squared minus 4x. And your YP is c2x squared plus c1x plus c naught. Okay, now what you need to do is to match this YP to the differential equation. You have your YP, but this differential equation have y prime and y double prime. So you need to have y prime and y double prime here by differentiate YP. Okay, differentiate this, you will get 2c2x plus c1. Differentiate this, you will get 2c2. And then what's next? Substitute these two differential equation. Okay. Y double prime is 2c2. Y prime is 2c2x plus c1 minus 2y. Y is c2x squared plus c1x plus c0. Why we need to substitute? Because we want to compare. Okay, we want to compare with the right hand side function there. Okay, now rearrange. This one, 2c2 plus 2c2x plus c1 minus 2c2x squared minus 2c1x minus 2c0. Rearrange minus 2c2x squared, then plus 2c2 minus 2c1x plus 2c2 plus c1 minus 2c0. Okay, now for those with x squared, compare with x squared. Okay. In the left hand side and right hand side, you have x squared and x squared. So you can compare. So from this one, minus 2c2 equals to 2. And you know, solving this, c2 equals to negative 1. And then for those with x, compare with x. So here you have 2c2 minus 2c1 equals to negative 4. Okay, so solving this, you have your c2 already, just substitute. Then you can get your c1, which is equals to 1. Okay, the next one. This one is a constant. Is there any constant in the right hand side? No. Then just equate them to 0. So now you have your c2 and you have your c1. Then you can find your c0. So c0 here minus 1 over 2. All right. Now you have, who is that? Please mute your sound. Okay. Now you have your c2, you have your c1, and you have your c0. And remember, your YP is c2x squared plus c1x plus c0. So now your YP becomes minus x squared plus c1x minus 1 over 2. So this is your YP. Okay? And this is your YH. And remember, our final solution should involve both YH and YP here. Then we can conclude that your YX equals to YH plus YP. Just add them together, which is YX equals to AE minus 2X plus BEX minus x squared plus x minus 1 over 2. So this is how you solve a non-homogeneous equation. Any question?
Kelas Kak.
Ya
No.
je.
Mak saya panggil.
Sekejap.
Lupa di batik.
Tu lah, tak apa. Bahasa habis tu. Atas tuang air tu.
Nanti.
Itu ಮಾತ್ರ.
Eh?
இந்த ஃபோனுக்கு மாத்திர மீட்டிங்.
Punita,
என் பேரை கூட்டுற போறாங்க.
Mumpul kau mana?
எனக்கா? என் கஜில.
okay, any question? Understand or not?
Yeah, Doctor.
No. So first, what you need to do is what? Find the solution for homogeneous part, characteristic equation, solve quadratic, identify the types of roots. Then that is your solution for YH. Okay, and then for the second part, check the right hand side function. Okay, is it polynomial? Is it exponential? Is it sine or cosine? Then follow the general form of YP. Okay, and then check is there any similar term with YH and YP by choosing the values of R from smallest 0, 1, 2, and so on. Okay, if no, then just proceed with matching with the differential equation. If yes, then repeat the process with the next value of R. Okay. Once you substitute to the differential equation, then you can compare left and right hand side to find the constant of YP. Once you get all the constant values, substitute back to YP and combine both YH and YP. Okay, clear everyone? Any question? No question. So far so good. This is easy, right? Okay, now let's try the next example by using method of undetermined coefficient. Okay, this is where there is similar term in YH and YP. Okay. So first, of course, you need to find YH. Okay, by changing to characteristic equation, solve for M, identify the types of roots, and this is the solution for YH. Right? You got M0, M minus 2, real and distinct. So A, E, 0x, which is A, plus B, E, minus 2x. So this is a solution for YH. Okay, next. Let's take a look at the right-hand side function. Fx equals to x. So this is a polynomial of degree 1. Okay, when it is a polynomial of degree 1, then your YP should be x to the power of R times C1x plus C0. Okay, start with R0. When R equals to 0, is there any similar term between YH and YP? So when R equals to 0, your YP becomes C1x plus C0. So this is a constant. This is a constant. Then there is a similar term between YH and YP. Okay. When there is a similar term between YH and YP, you need to proceed with the next value of R. Then we cannot use this as your YP. Okay. This is the difference between the previous example. When you have no similar term, then just take it, your YP there. When R equals to 0, just take it, your YP. But now, your similar term, there is similar term in YH and YP when R equals to 0. Then we cannot take this function at R equals to 0. Then just proceed, R equals to 1. So, when R equals to 1, this is x to the power of 1 times with C1x plus C0, combine, expand, and then check again. Is there any similar term between YH and YP? Then if it is no, then that's it. That is your YP. Okay? So this is your YP. Why there is no similar term? Because this is a constant. This is exponent. This is x squared in terms of power 2. This is x. So no similar term. Alright? So now it is no similar term. There is no similarity between YH and YP. Then this is your YP. What you need to do is to match this YP to the differential equation here. So your differential equation given y double prime plus 2y prime equals to x. So match with this, you have your YP. You should have your YP prime and YP double prime. And substitute here and compare. Okay, compare to get the value of constant C0 and C1. Once you get the value of constant there, just substitute again to your YP and combine YH and YP to get your final answer. Is that clear? This is how we do it. Okay, let's try. You can try to find the solution by your own, and then you can compare. Okay, try it. Any question? Okay, let's try another example. Same process, right? But check the similarity. Okay, let's do this together since I forgot to record previously. But now you know how to do it, right? Okay, so what is your first step? Okay, let's do this together. Come on. Let me not be the one as can speak today. We have how many participants? 43, 44. Yes, come on. Okay, what is our first step? Should I call the name or you want to volunteer?
We find the YH.
Okay, good. YH. Okay, thank you, Dayang. Change to the characteristic equation, right? You know that this is y double prime plus 2y equals to... No, Dayang reply the chat box. Okay, this one, y double prime plus 2y equals to 3x exponent minus 2x, okay? And thank you, Chandran. We need to find YH by convert this to characteristic equation, m squared plus 2 m equals to 0. Okay, and you will get your m is 0 and minus 2, right? So your function of YH should be what? A plus okay. This is your YH. Okay, next. What is your YP? Okay, looking at the right function, the right-hand side function, your fx is 3 exponent minus 2x. Now, your YP should be x to the power of r, d, e to the power of minus 2x. Okay? Okay, let's check. When r equals to 0, then YP equals to d e minus 2x. So, is there any similar term between YP and YH?
Yes.
Yes. Okay, yes. there is similar term. So what's next? Let's choose when r equals to 1. Okay. Then when r equals to 1, your yp becomes x d e minus 2x. So is there any similar term?
No.
No. Okay. Then we stop at r equals to 1. Okay. So this is your yp. Okay, identify your yp and yh. This is your yh and this is your yp because no similar term. So what you need to do here is to match with the differential equation. Y double prime plus 2y prime equals to 3 exponent minus 2x. Your yp is x de minus 2x. So just find your yp prime, yp double prime, substitute and find the constant there. Okay. All right, try it. So this one you should use product rule. Okay, let's try this one. Your yx should be a plus